In this class, I will be discussing about the Bohr's hydrogen atom model. So, according to Bohr, the electrons are revolving around the nucleus. Let me say this is the electron and this is the nucleus. It has circular orbits, and with the help of the circular orbit, this electron can easily travel around the center part of the atom, that is nucleus. So in this topic we will be discussing about the Bohr's concepts. Second, how he determined the radius of hydrogen atom. Third, based on that is we will be discussing about the energy associated with the electron. Okay. Bohr's hydrogen atom, where he has explained very nicely about the radius of the orbit. Let me take up first this concept, that is radius of the orbit of the electron. Take down radius of the orbit of electron and the velocity of the electron. So we will be discussing about the velocity of the electron also. Velocity of electrons. Now we have this orbit, that is, it is the two-dimensional part where the electrons are revolving, and this is the nucleus. Let me consider this as the electron. Likewise, it will be traveling various circular orbits, but the hydrogen atom has got only one electron, so in that case we consider only one, right? And you know very well, Z means what? The atomic number, is it not? Atomic number. Z means atomic number. And E is the charge of electron. E is the charge of electron. And you know, in a nucleus you have proton and neutron. Proton and neutron. Let me consider the proton here. As far as hydrogen is concerned, we have got only proton and electron is there. Now, the proton is positively charged, electron is negatively charged. So, charge wise they have same but opposite signs. They have opposite signs. What is the charge of electron? 1.6 into 10 power, how much? Minus 19 coulomb. So, it has got the negative charge. So, you can put minus 1.6. If it is electron, minus 1.6 into 10 power minus 19 coulomb. If it is proton, it has got the same charge but opposite. Plus. So, for proton, what is the charge? The proton charge is plus 1.6 into 10 power minus 19 coulomb. Okay? Right. Now, let me consider the distance between the nucleus and the electron. This is the radius R. Okay. Since it has only one orbit, we can say R. If it has n number of electrons in different orbits, then you can mention this as Rn. So what do you mean by Rn? Rn is the radius of nth orbit. It can be first orbit, second orbit, third orbit, like that. So radius of nth orbit. You know very well, if it is R1 means first orbit, radius of first orbit. Correct? If it is second orbit, radius of second orbit. Likewise it goes. If it is nth orbit, it is the Rn. Okay? So this is what it means. Now let us consider the hydrogen atom that contains the nucleus. Of course, nucleus is at rest, is it not? An electron is revolving around the nucleus in a circular fashion, circular orbit, and its radius we already mentioned this as Rn, right? And you know very well the nucleus is made up of proton and neutron. Okay. In fact, the charge of the nucleus is entirely due to the proton, not due to the neutron. Why? Because neutrons have no charge. So nucleus is positive because of the presence of positive charges, which is nothing but proton, right? Okay. Now, see, for any element, we can represent this as X, any element. Usually we have the custom of writing the atomic number at the left subscript, and on the left superscript you can write mass number, and at the top of the right side, that is right superscript, charge we used to write, oxidation number, and here we used to put the atomicity. For example, when I mention H2, S8, sulfur, O3, ozone, so these are all the atomicity, number of atoms present in a molecule. And here this represents, so A represents atomicity, you should never forget this. And what about this? This is charge, whether it is plus or minus. For example, we put Na plus, H plus, Cl minus. So these are all charges, and it is also called oxidation number. Okay. And this Z, that is Z, is nothing but atomic number. Atomic number. So this atomic number is nothing but number of electrons. But for an atom to be neutral, it should be equal to the number of proton also. Therefore, Z can be either number of electrons or number of protons, right? They should be equal in number. That is why the atom should be neutral. And what about A? A is called mass number or atomic mass. So A is nothing but number of proton plus number of neutrons. In fact, we can add number of electron also, but compared to the protons, the mass of proton, the mass of electron is negligible, so we don't consider this. So we had to consider only this. Are you able to follow? Right. So this is called mass number. Now I have say for example, what is the number of electrons present in carbon? 6. What about its atomic mass? 12. Are you able to follow? So this is the way we represent the atom or any element. And what is this? This is atomic number. What is this? This is the mass number. You know very well mass number is equal to number of protons. Number of protons is nothing but Z. So you can put Z plus number of neutrons. So by having this equation, now you can count the number of neutrons also. How? Number of neutrons can be calculated by subtracting Z from A, right? You can bring the Z. So mass number minus atomic number gives the number of neutrons. It gives some idea about the number of neutrons. For example, in the case of carbon, you have got two types of isotopes, major type, that is C14 and 6. So what is the neutron number here? It is A minus Z. So 12 minus 6, that is 6. Whereas in this case, 14 minus 6, that is equal to 8. So it means it is because of the change in the number of neutrons, the atomic mass varies. And that is why we call them isotopes. They have same atomic number but different mass number. Now, I am giving you just some rough idea about the basic concepts so that we can go comfortably. Now, we talk about the charge carried by. When I say Z, it indicates number of protons or number of electrons, correct? So, what is the number of, atomic number of hydrogen? It is 1. What is the atomic number of helium? It is 2. Are you able to follow? So, like it goes. What is the atomic number of sodium? It is 11. Right? So, in that case, we consider only the number of electrons here. That is equal to number of protons. Let me consider the hydrogen atom. Okay. So, when I put Ze, what do you understand from this? Ze of hydrogen. Okay. This represents the what? It has got only one proton. So, its charge is, if it is a proton, if it is electron, what about the charge here? This is how much? 1.6 into 10 power minus 19. This is of minus charge. And Z is equal to 1. So that is the charge. So 1 into, right? And what about this is plus. And here 1 into 1.6 into 10 power minus 19 coulomb. Suppose this is Ze of helium. In that case, what about the proton? How many protons are there? 2 protons. Okay. So there are 2 protons and 2 electrons. In that case, what is the charge? That is equal to 2 into 1.6 into 10 power minus 19. Do you understand this point? Charge, coulomb. And here it is 2 into minus 1.6 into 10 power minus 19 coulomb. Do you understand this? Okay, right. I think now you have better clarity. So, when I put Z, you have to introduce the atomic number. But as far as hydrogen is concerned, it is after all 1. Okay, but it should be applicable. When I talk about the Bohr's hydrogen atom, it should be applicable for other atoms also. In fact, he was able to go up to helium, other small atoms only. So, let me have the general format. So, Ze is the atomic number into charge. That's all. Okay. Is it clear now? So, Z is the atomic number. When I put plus Ze, it represents what? The proton, the charge of the nucleus. Are you able to follow? And if it is a minus means minus E. Minus E is charge of electron. So, what about this? This is charge of proton. Charge of proton. This one, charge of what? Electron. Okay, that is why it's minus. Right? Now, see, that is when we have 2 charges, because as we already discussed, in this case, you have the proton here. One proton is there, one electron is there. These are the 2 differently charged bodies. And the distance between them is nothing but the radius. Okay. So here, there should be some electrostatic force of attraction, is it not? So we had to consider the Coulomb's law. So according to Coulomb's law, Coulomb. So according to Coulomb's law, the force of interaction between 2 charges, okay, is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Is it not? This is the basic formula. Okay, take down. So what is F here? The force, the electrostatic force, okay, or the force of attraction. So in this case, positive and a negative, is it not? So the force, we can apply the same here in the case of hydrogen atom. So let us represent by the vector. So F vector. F vector is the force vector, and that is the Coulombic force. So you can put COULOMB, Coulomb. The Coulombic force of interaction is equal to, when you remove the proportionality, you have to introduce the constant. Okay, that constant is here 1 by 4 pi epsilon naught. Take down. Do you understand? 1 by 4 pi epsilon naught. So this epsilon naught is the permittivity through free space, right? So you can mention this is the Coulombic force of attraction, and I removed the proportionality, so we can introduce the constant and put equal to into, and what is the charge of proton? The charge of proton, and we have got n number, so we can put atomic number, and this is the proton charge into, and what about electron? Electron has minus charge, is it not? So you can put minus E. Do you understand this?
Yes.
And this being the vector, okay, so you have to consider the vectorial equation, that is Rn squared into, and you have to put the R cap. This is the unit vector. What is this? Unit vector of the radius. Unit vector of radius. You understand? And what is Rn? Rn we already know, that is a radius of nth orbit of the electron. Okay, right? Next, now that is equal to, so we can bring this minus here, minus 1 by 4 pi epsilon naught into Z, and then E squared divided by Rn squared, right? And R cap is there. Okay. Now we have discussed about the Coulombic force existing between the the proton and the electron, and we have another force, that is nothing but the centripetal force. Okay, so let us discuss that one. Centripetal force. Centripetal force. This can be represented, once again, being force being a vector, you can put centripetal. Okay, centripetal. And this force, that is vector, centripetal force vector, let me put cent. Centripetal force vector is given by mv squared divided by r into r cap. These are all vectorial equations. And we are considering the electron in the nth orbit. So you have to put the velocity of electron traveling in the nth orbit is Vn. Similarly, Rn. Okay. Since it is a unit vector, you need not put that one. So, what is Vn here? So, we have various orbits. For example, this is R1 and the velocity of this electron is Vn. It means velocity of the electron traveling in the nth orbit, because it can have n number of orbit, is it not? So you can have a lot of things. So nth orbit, right? Okay. So Vn is equal to velocity of electron in the revolving in the nth orbit. Don't forget this orbit. Okay, right. Let me consider this as the equation 1. So this is the force, Coulombic force, Coulomb force. This is equation 1. Done. And so here we have, that is centripetal force, that is given by mvn squared divided by rn into r cap. And what this m, this is nothing but mass of electron. Are you able to follow? Mass of electron. After all, it won't vary. For example, mass of electron in the nth orbit, in the first orbit, in the second orbit, they remain same, right? So you need not put mn. Instead, you can have simply m. Clear? Okay. Now, what is this v? That is the velocity in the circular orbit. Velocity of electron in the circular orbit. That is nth orbit. Now, we start this derivation based on this fundamental concept. That is, these two forces, Coulombic force is equal to vector, equal and opposite to what? That is F. And this one, what is this force? Centripetal force. This is equal and opposite, and we will take the modulus. Modulus means its charges, that is its negative sign will go. We take the absolute values only. Okay. Now, what is the Coulombic force here? We already done. What is this? 1 by 4 pi epsilon. We can rewrite this. Minus 1 by 4 pi epsilon naught into ZE squared divided by Rn squared into R cap. This is modulus is equal to, what about this one? M Vn squared, is it not? M Vn squared divided by Rn into R cap modulus. So once you release from the modulus, it becomes positive, is it not? Okay, so let me rewrite. I am removing the modulus, so it becomes what? So modulus of minus becomes plus. So we can have 1 by 4 pi epsilon naught and then ZE squared. Do you understand why I have removed the minus? Because of modulus. I have taken only the positive value, absolute values. So ZE squared divided by Rn squared, correct? Into, what is that? R unit vector, that is R cap, that is equal to, let us put mvn squared divided by R, okay, into R cap, right? Now we can comfortably remove this R cap, and this is Rn, R, and this is Rn actually, Rn, okay? So we can remove everything, and we want to have Rn here. Are you able to follow? Let us have Rn, right? So we can bring this Rn this side, Rn squared divided by Rn, okay? And bring this mvn squared this side. So 1 by 4 pi epsilon naught is there, ZE squared. I have taken already Rn squared on the other side, and here mvn squared can be brought here. Is it clear? Now we can strike out and declare Rn as 1 by 4 pi epsilon naught into ZE squared divided by m into Vn squared. Got it? Okay. Next, so what I have done, Rn squared I brought here, so Rn squared, and mvn squared I brought here, and Rn and Rn squared cancel. Now we declared Rn is equal to this much, Ze squared divided by 1 by 4 pi epsilon naught. Is it not? Now let me keep like this, and let us take it in another way also. So you have 1 by 4 pi epsilon naught into Ze squared divided by mvn squared is equal to what? Rn squared. So that's what we already written. Okay. Now this Rn, now that is we want to have Rn. Let us retain this Rn because it is required here. So let us not completely eliminate. So what I want to do is, we'll have this 1 by 4 pi epsilon naught, okay, Ze squared divided by Rn squared, that is equal to mvn squared divided by Rn. I have eliminated here only the what? The R cap only. Right? Now multiply and divide by m here. Okay, multiply and divide by m, so that you are able to get what? Multiply, that is the m is cancelled and you can bring this. Okay. So it becomes Rn is equal to, that is multiply and divide by m means m divided by m. Are you able to follow?
Yes, sir.
So that you are able to get Rn is equal to 4 pi epsilon naught. You have to put here 4 pi epsilon naught, and then m into v into, that is a vn Rn whole squared. Okay, Rn whole squared and divided by Z m e squared. Okay, Z m e squared. See, that is I am multiplying and divide by m, so it becomes m squared. Is it not?
Yes,
M squared, and m squared means m whole squared, and this r vn squared. Okay, and you have got this Rn, so I have put Rn. Right? Now I have taken this Rn this side, so Rn. Okay. Are you able to follow? And 4 pi epsilon naught has come this side. So I have made this as Rn. Now according to Bohr's concept, Bohr's assumption, the angular momentum is given by mvr, that is mvn Rn for nth orbit. That is given by angular momentum Ln. Okay, and this is called the angular momentum quantization condition. So that is given as the integral multiples of h. So we can call it nh, where h is the Planck's constant. H is equal to Planck's constant. So we have now mvRn is equal to Ln, that is equal to nh. Okay. So here let me reproduce this. Rn is equal to is equal to 4 pi. This 4 pi has gone here. So 4 pi epsilon naught divided by z m e squared. Okay, z m e squared, and then we have this mvn rn. This mvn rn is nothing but nh. Are you able to understand this? So we can replace this. Okay, so let me put n squared h squared, correct? Because we already declared nh according to Bohr's postulate. This is the angular momentum quantization. So nh is mvn rn. So I have put mvn rn. Do you understand? So here I have taken only rn so that you are able to get this equation. But our objective is not to consider this. We have to introduce that nh in terms of, we want to declare this in terms of nh. So I want to retain this, and that is why I have taken this equation. Okay, so 1 by 4 pi epsilon naught, and what I have done here, this is a very important step. Multiply and divide by m so that you are able to get m squared. And what about this? This also comes here, m. Okay, and I have taken 4 pi epsilon on the other side. Do you want me to redo this one? This is confusing. Let me explain once again. So 1 by 4 pi epsilon naught into z e squared divided by r n squared is equal to m v n squared divided by r n. So just by looking at this equation, we will have the tendency to remove this r n, but that is not our objective. It should be included. At the same time, it should be interpreted in terms of what? nh. We know nh is equal to what? nh is equal to mvnrn. So we want to have this term. How can you get this term? By multiplying by m, because we can put the whole square, is it not? So what I am doing is, I am multiplying the right hand side equation m and divide by m. Okay, either you have to do multiplication on both sides, or you can do multiply and divide by the same number or the same term on one side. Now I can have m squared vn squared, correct?
Yes, sir.
And divided by rn. Okay, now you have, let me write step by step. 4 pi epsilon naught into z e squared divided by rn squared. Okay, now I want to have mv and rn. So let me bring this here so that you will get mvn, is it not? So I am bringing to the other side. So m squared vn squared rn squared, correct? Divided by rn. Don't strike out immediately because we want to retain, and we are going to convert this into nh, and that is why I have to make. And you have now 1 by 4 pi epsilon naught, okay, into z e squared, because this has already gone, right? So I want to release this one to the LHS. We are interested in Rn because our objective is to find out or to determine the radius of the nth orbit. So let us bring here. So Rn, and what about this? This will be reciprocated on the other side, okay? So that you are able to get Rn is equal to, now this can be written as m v n Rn whole squared, am I right?
Yes.
And z e squared will come down to the denominator, right? Into what? 4 pi epsilon, I mean this will go up, okay, into 4 pi epsilon naught. Is it clear now?
Yes, sir.
Now I can put mvn rn, that is equal to ln, that is equal to nh. So we can replace this by nh. Is it clear now? So I can take up like this, that is, I am replacing this by nh. So Rn is equal to nh whole squared divided by, and you can put 4 pi epsilon. Shall I write in the next page? that is Rn is equal to, and then Vn Rn is replaced by NH. So NH the whole squared, correct? Divided by, so into you have 4 pi epsilon. Okay? 4 pi epsilon naught divided by Ze squared. Now it is clear? Okay? So you need not write all these things in your examination, but you should try to get to the next step. Okay? But if you have got any problem in arithmetic, you have to do it. There is no other book, not the algebraic. And now I hope now it is clear. So what is Rn here? Rn is equal to, Rn means nth orbit. Radius of the nth orbit is equal to 4 pi epsilon naught into n squared h squared divided by Ze squared. This is the formula. So now we have derived the what? Rn. And this Rn actually we used to say that is this h. I want to have a better clarity here. Usually we can put h bar, h cross you can say. This is h cross. Actually h cross is nothing but h by 2 pi. Okay?
We have to mention.
Yeah, you have to mention. You have to put h cross. So h cross means h by 2 pi. And h is Planck's constant. Okay? So first we introduce n squared h cross squared. H cross squared. Okay? Now you can substitute this. H cross is nothing but h by 2 pi. Am I right? Now you can introduce once again. So Rn is equal to 4 pi epsilon naught divided by Ze squared into n squared into h cross squared means h squared divided by 4 pi squared, right? H squared divided by 4 pi squared, right? Because 2 2s are 4 and pi squared. Okay? Now you can cancel this 4 pi. Okay? So write the remaining 4 cancelled, pi squared here pi only. Okay? So you have now n squared h squared, that is epsilon 0 is there, and then h squared, okay, divided by pi is there, and then you have, I think I have left m here, you should have m here. Okay, so m pi m, and you have e squared into n squared divided by z, that is equal to Rn. And again, now you should be able to give all the values. So what is epsilon? Permittivity through free space. H, Planck's constant. H cross means that is h by 2 pi. So we have already replaced this. Pi is a constant, and n, that is the integer, that is 1 2 3 4 nth level, nth orbit. Okay, E, charge of electron. Okay, so the charge of electron in Coulomb. Z, atomic number. So these are all constants, is it not? So the only variables are here, that is n. Of course, n belongs to natural number, is it not? It cannot be 0. So it belongs to natural number. So it can be 1 2 3 orbit levels. Are you able to follow? And what about the epsilon? Epsilon is a constant, and h is also constant. E, charge of electron is constant. Pi is also constant, 3.14. So these are all constants. So it means you can bring this as a constant one, is it not? So you can simply represent this as Rn is equal to, let us put a constant A naught. Okay, this A naught is nothing but the constant, the proportionality constant, which is nothing but what? Epsilon naught h squared divided by pi value m You know the mass of electron, that is also constant, is it not?
Yes.
And you have the charge of electron squared. So you can substitute all these values and it is found to be 0.529 into 10 power minus 10 meter. Okay, and this can be converted into Armstrong. So 0.529 10 power minus 10 meter is Armstrong. So it can be represented as Armstrong. Okay, so A naught value is this one. So Rn is equal to A naught into the remaining term n squared by z. So you can put n squared by z. So this is the final reduced equation. This is the expanded equation. Both of them are important. Okay. Is it clear?
Yes.
So for hydrogen, you know Z is equal to 1. Is it not?
Hydrogen.
For hydrogen, atomic number is 1. Therefore, for hydrogen atom, for H atom, Z is equal to 1. So we can substitute this Z by 1. Is that not? Therefore, for hydrogen atom, Rn is equal to A naught into n squared. That's all. Because Z is equal to 1. So you can further reduce for hydrogen atom. Are you able to understand?
Yes.
And now Rn is equal to, let me say that is, what is the value of A naught? A naught is 0.529 Armstrong. Okay. Now suppose you have got the first orbit. Here you have got the nucleus. This is first orbit, that is n is equal to 1. Second orbit, n is equal to 2. Third orbit, okay, n is equal to 3. So when the electron is revolving in the first orbit, that is when n is equal to 1. So what could be the value? R1 is equal to, what is the value of A naught? 0.529 Armstrong, because 1 square, that's all. Now when for hydrogen, this is all applicable for hydrogen. When n is equal to 2, that is, it is traveling in the second energy level or second orbit. So you have to put R2 is equal to how much? That is a 0.529 into 2 square, correct? So that is equal to 4 into 0.529. Okay, so 4 nines are 36, balance 3, 8, 11, balance 1, 20, 21. So 2.116. Okay, this much Armstrong. This is R2. Right? Can you calculate the radius of the orbit? Radius of the third orbit, assuming that the electron is revolving in the third orbit. So what could be that? Can you try? When n is equal to 3, so R3 is equal to 0.529 into 3 square. So that is equal to 0.529 into 9. So you can multiply and it becomes what? 1, 6, 7, then 4. So 4.761. How much? This much Armstrong. Is it clear? So from this, now you can eliminate this A naught so that you can introduce the proportionality. Am I right? So Rn is proportional to, this is another equation. You can introduce this. What is that? I am removing this so that you can put Rn is proportional to n squared. So what do you understand from this? With the increase of what? N. Okay, the Rn increases. Are you able to follow? So it means the Bohr's radius is also used as a unit of length called Bohr. So 1 Bohr is nothing but 0.53 Armstrong, and that's what this when 1 Bohr. So what do you mean by that? When I say 1 Bohr means it is also a unit of radius of an atom. Do you understand? So 1 Bohr is equal to what? How much? 0.529 Armstrong. Do you understand? Okay. So roughly what could be the diameter of hydrogen atom? 2 R. Okay. So take down, calculate the diameter. This is the hydrogen atom nucleus. So this is found to be R1. Okay. Assuming that the electron is revolving in the first orbit. And what is its value? It is 0.529. Is it not? So R1 is equal to 0.529 Armstrong. So I asked you to find out that is the diameter. Okay. So which is nothing but 2R. So diameter is equal to 2R1. Therefore 2 into 0.529 Armstrong. Okay. So 58. This is 1. So it means 1.05 is the dia. 1.058 Armstrong is the diameter of hydrogen atom. Are you able to understand this?
Yes, sir. So we have to draw this and then we have to derivate it, sir.
Which one?
We have to draw that and then we have to do it, sir.
No. Just for better understanding, I am explaining. So they won't ask such type of questions in normal one, but they may ask. Assuming that since that is the value of R, you should be able to calculate R2 also twice. R2 is different. Okay, clear? So you can derive the equation up to this. So shall we summarize? Now follow me carefully. Right. So we started like this. Radius. This is the derivation for what? Or determination of radius of the orbit of electron. We are not yet discussed the velocity. I am talking about only the radius. So the first thing is, as I already mentioned, you have the various orbits. Electrons are revolving in the circular orbits. Okay. So we discuss all these things. But when you derive the equation in your examination, you just draw the diagram and straight away these are all fundamental explanations only. And I already explained these things. You need not write all these things. Start from Coulomb's law. So how you had to start? See, that is, let me have a mind map for this so that it will be very helpful for you. So I'll try to summarize this in a different way so that you can easily derive. So how to start this? For example, what is our objective? Determination of Rn, that is nth radius, a radius of the nth orbit of hydrogen atom. So this is our objective. First, how I have proceeded? The first one is you have to consider like this: F vector Coulombic interaction. The modulus is equal to the modulus of F vector of what is that? Centripetal force. Centripetal force. Okay. Now this is the first one. You should remember this. Second, what is the definition? What is the equation for Coulombic force?
1 by
So that is equal to, what is that? 1 by
4 by
4 pi epsilon naught into Z E squared divided by
m
R
r
N squared into
r cap.
R cap. Okay. And what about this? This one is the centripetal force. That is given by m Vn squared divided by
Rn
Rn into
r
R cap. Not R vector, R cap.
okay.
So, okay, or cap. So this is, it should be or cap. Okay, so correct it, or cap, right? And so this is the second stage. And third stage is, you should be, you have what we did, we removed the minus sign because of the modulus. Okay, so take care of this minus sign, you have to remove. Why? Because we have put the modulus. And the third step is, you have to multiply and divide by m. Don't strike out like this, because we need it. Okay, what is our purpose? Because we know, so you have to do like this and rearrange it entirely and declare Rn is equal to what we have done. Rn is equal to 4 pi epsilon naught into m Vn Rn whole square divided by Z m E square. Don't forget. Okay, so Rn we have retained, and this we have done by multiplying and divide by m. So don't forget this step. This is a very important step. And the fourth one is, that is, we should know this m Vn Rn is equal to the angular momentum, that is equal to, it is a quantized, means it can be counted. Okay, so nh bar or nh cross, and we already know that is h cross is a h by 2 pi. Don't forget this also. This is the fourth step. Do you understand? After that, what we did, we just substituted this one. Okay, so that we were able to get Rn in terms of nh. So that is the fifth step. Fifth step. What is that? Rn is equal to 4 pi epsilon divided by Z E squared into, we put n h bar, n squared h squared. Okay, this is the another important equation, n squared h bars h cross square. Are you able to follow?
Yes, sir.
And never forget to put m, E squared m. And finally we replaced this by h by 2 pi. So h bar is equal to h by 2 pi, so that we were able to reduce this, and Rn is equal to, what is the final equation we got? Epsilon naught h squared divided by pi into m into E squared into n squared divided by Z. Then we declared it is for hydrogen, it is 1. Okay, and the seventh step is Rn is equal to E squared h squared pi m E squared into n squared only. And eighth step, we declared this one as A naught, that is equal to 0.59 529. Okay, 529 Armstrong. So never forget, right? And then Rn is equal to, you can straight away put A naught into n squared. Okay,
Yes.
and since it is constant, finally you can declare Rn is proportional to n squared. That's all. Okay, you can simply write all these things, but you have to express all this constant nicely. Okay, do you understand this? So we have discussed up to the radius of what? The hydrogen atom in the according to Bohr's constant. Is it clear? Any doubt?
No, sir.
So initially, that is, I attempted this one as Rn, but don't take it that. I think I already explained about that already. Okay, right.